Hello everyone, welcome to my class. Today I am going to cover trigonometric substitution technique to evaluate an integral. So our goal in this section is to explore how to compute the integrals with radical integrand, such as integral of radical a square minus x square to integral of radical a square plus x square 3 integral of radical x square minus a square. So for each of these integrals we have a different idea. So idea to remember to evaluate such integrals, correspondingly substitute the following. For the first integral, substitute x equals to a sine theta, where a is constant. Theta is angle between negative pi half to positive pi half. Then use the trig identity 1 minus sine square theta equals to cosine square theta. Then to evaluate the integral of second type, put x equals to a tan theta. Again, a is a constant. And use the trig identity 1 plus tan square theta equals to secant square theta. To evaluate the integral of type third, which is integral of radical x square minus a square, substitute x equals to a secant theta. A is constant. And use the trig identity secant square theta minus 1 equals to tan square theta. Remark, to save a heavy algebras, let me scroll down. To save a heavy algebras, a reference triangle can be used. The idea is to create a right triangle out of the integrand functions and correspondingly substitute x over a equals to sine theta to evaluate the first integral. To evaluate the second integrals, put x over a equals to tan theta, and to evaluate the third integrals, put x over a equals to secant theta. And at the very end, we must reverse the substitution and get the original variable x. Now let me talk on the right triangles here. So for the first type, we put x over a equals to sine theta. So the sine theta in right triangle, sine theta is the ratio of perpendicular and hypotenuse. So that means x is my perpendicular on my triangle, a is my hypotenuse. Then by Pythagorean theorem, base must be radical a square minus x square. Similarly, in the second diagram, we put x over a equals to tan theta. In the right triangle, tan theta is the ratio of perpendicular and base. So x is perpendicular, base is a. Then by Pythagorean theorem, hypotenuse must be radical a square plus x square. Similarly, in the third diagram, we put x over a equals to secant theta. So keep in mind, secant theta is the reciprocal of cosine theta. So cosine theta is base over hypotenuse. So that means the secant theta is hypotenuse over base. So x is hypotenuse, a is base. So then our perpendicular on that right triangle must be radical x square minus a square. Awesome. Now with those idea, now let's evaluate integrals involving radicals. So worked examples. First example, evaluate the integral x over radical 9 minus x square dx. So it's a first type, so we put x equals to 3 sine theta. Now here a is 3. And take the derivatives, dx equals to 3 cosine theta. The sine theta derivative is cosine theta. And on the diagram side, on the right angle triangles, we put sine theta equals to x over 3. So theta is angular reference, then x is my perpendicular and 3 will be my hypotenuse. Then by Pythagorean theorem, the base must be radical of 9 minus x square. Great. So now let me talk to the solution side here. So we put x equals to 3 sine theta, then dx equals to 3 cosine theta d theta. Then let's rewrite our given integral in terms of new variable theta. So x equals to 3 sine theta, and my denominator radical as it is, So 9 minus x is 3 sine theta, x square is then 9 sine square theta, so 9 minus 9 sine square theta, and dx is 3 cosine theta d theta. I hope it makes sense to you, theta integrals. Great. Now let's cancel here. So let me simplify this denominator. So radical 9, I can pull the 9 factoring out, then what left? 1 minus sine square theta, which is cosine square theta. Then out of the radical, so 9 becomes 3, cosine square becomes simply cosine theta. Great. Then even I can cancel this 3 cosine theta, then I have only 3 sine theta left. So in my next step, I multiplied first. Okay. So in the next step, let's multiply 3 times 3 on my numerator, which is 9. Sine theta as it is, cosine theta as it is, d theta over this 3 cosine theta. Then cancel 3 cosine theta cancel, and 3 cancel 9 3 times. So I have 3 sine theta left. Then the integrals of 3 sine theta is negative 3 cosine theta plus c. We know integral of sine theta produce negative cosine theta, right? And c is the constant of integrations. Now let's reverse the substitutions. So in the next step, negative 3 as it is. Now I can pull theta from this our substitution, which is sine inverse x over 3, but I rather use this triangle to write the theta in terms of x. So from this triangle, cosine theta is base over hypotenuse, so radical 9 minus x square over 3, so I put it here, and plus c. Simplify this, cancel 3, so what left? Negative radical 9 minus x square plus c. Awesome. Now let's move on. Example 2. Evaluate the integral radical x square minus 4 all over x cubed. So it's an integral of type third, so we put x equals to 2 secant theta and take the derivative. Dx equals to 2 derivative of secant theta is secant theta tan theta d theta. Also on my numerator, radical x square minus 4 equals to radical, here x square is from our substitution, 2 square secant square theta, 2 square is 4, so I can pull the 4 outside. Then what left? Secant square theta minus 1. In the next step, radical as it is, 4 as it is, we know secant square theta minus 1 is tan square theta. And let's pull everything out of radical. So 4 out of radical is 2. Tan square theta outside radical is simply tan theta. So we have 2 tan theta on my numerator. Awesome. And also let me talk about this right triangle here. So we put x equals to 2 secant theta. That means secant theta equals to x over 2. So that means x is my hypotenuse, 2 is my base. Then by Pythagorean's theorems, my perpendicular must be radical x square minus 4. So now, let me scroll down. Now let's rewrite our x integral in terms of theta integral here. So then, this is radical x square minus 4, we found 2 tan theta, so we found 2 tan theta here. And my denominator x cubed is 2 cubed secant cube theta. So 2 cubed is 8 secant cube theta. And dx is 2 secant theta tan theta d theta. Great. Next, let's simplify. So first constant. So in my numerator, it's 2 times 2 is 4. Cancel the 8 on my denominator, so it's 2 times, so 1/2. And 1 secant theta cancel on my numerator and 1 cancel on my denominator. So on my numerator, tan square theta left. On my denominator, secant square theta left, d theta. I hope this makes sense to you all so far. Great. So now let's move on. On my next line here, 1/2 constant as it is. Then tan square theta over secant square theta is simply sine square theta. So tan square theta is sin square theta over cosine square theta, and secant square theta is 1 over cosine square theta. So that means we can cancel the cosine square theta and left only sin square theta. Then 1/2 as it is, and my next step. So the sin square theta, let's apply the trig identity. Sin square theta equals to 1 minus cosine 2 theta over 2 and d theta. Let me scroll down. So then 1/2 and pull the 1/2 out, so 1/4 constant outside. Integral of 1 with respect to theta is simply theta, minus integral of cosine 2 theta is sine 2 theta over 2, plus constant of integration c. Now we can use the trig identity again. Sine 2 theta is 2 sine theta cosine theta. Then we can cancel the 2. So I have 1/4 theta minus sine theta cosine theta plus c. Then let's resubstitute the variables. So 1/4 as it is. Theta is secant inverse x over 2. From here, theta equals to secant inverse x over 2. And now sine theta cos theta. Now I'm going to use this triangle. So the sine theta is perpendicular over hypotenuse. So sine theta equals to radical x square minus 4 over x. And for the cosine theta is base over hypotenuse. So the cosine theta equals to 2 over x. So let me scroll down. That's what I wrote here. Sine theta is radical x square minus 4 over x. Cosine theta is 2 over x plus c. Awesome. Let's continue. Let's do example 3. Example 3, evaluate integrals x times radical 1 minus x squared dx. So this example, two ways to evaluate these integrals. One, we can use a trig substitution where x equals to sine theta. Here a is 1. Or we can simply use u substitutions where we put 1 minus x squared equals to u. So let me do this example with u substitution. Just a quick reminder for you all also. So put u equals 1 minus x squared, then its derivatives. U derivative du, derivative of 1 minus x squared is minus 2x dx, and x dx equals to divide by negative 2 both sides, which is negative d over 2. Then rewrite the given integral in terms of u. So integral radical 1 minus x squared becomes simply radical u, and x dx is simply negative half du. Then the next step, minus 1/2 constant pull outside, and the integral of radical u. Radical u means u power 1/2. Integral of u to the power 1/2 is u to the power 1/2 plus 1, which is 3/2, divided by 3/2. Dividing is same as multiplying by its reciprocal, so you just flip that 3/2 to 2/3. So in the next line here, minus 1/2, 2/3, u power 3/2 plus c. And then reverse the substitution, put u equals to 1 minus x squared. So what I wrote here, so you simplify, cancel 2 minus 1/3 left. U is 1 minus x squared power 3/2 plus c. Awesome. Now let's continue. This time let's evaluate integrals. It's a definite integrals. Integrals going from 0 to 2 of 1 over radical 4 plus t square dt. So it's a good candidate for putting t equals to 2 tan theta. So then put t equals to 2 tan theta. Then the derivative of t is dt, derivative of tan theta is secant square theta, 2 as it is. And in my right triangle here, we put tan theta equals to t over 2. That means t is my perpendicular 2 is my base, then my hypotenuse must be radical 4 plus t square using Pythagorean theorem. Now on our substitution, let's change the limit of integrations also. When t is lower limit is 0, then 0 equals to tan theta, means theta equals to 0 degree. When t is upper limit is 2 cancel, tan theta equals to 1, that means theta equals to pi fourth. So in the next step, let's rewrite the given integral in terms of theta. So one more computation here for my denominator. So radical 4 plus t square equals to radical 4, t square is 4 tan square theta. Then we can pull the 4 outside the radical, which becomes simply 2. Then inside is radical 1 plus tan square theta, which is secant square theta. And pull the secant square theta outside the radical, becomes simply secant theta. So I have 2 secant theta left. Great. So let's rewrite the given integral. So my limit of integration becomes 0 to pi fourth. First take care of the denominator. So 1 over radical 4 plus t square is 1 over 2 times secant theta. We computed before. And numerator dt is simply 2 secant square theta d theta. Correct? Let me scroll down. Yeah. Then let's simplify first. So 2 cancel, 1 secant theta and 1 secant theta cancels. So on my numerator, only secant theta left. So the integral 0 to pi fourth of secant theta d theta. Then the integral of secant theta is natural log of secant theta plus tan theta. That's the formula. And limit 0 to pi fourth. Then evaluate this function at theta equals to pi fourth, upper limit minus lower limit, theta equals to 0. So natural log secant pi over 4 is simply radical 2 plus tan pi over 4 is 1 minus, this is coming from the formula to put the lower limit, ln secant 0 is 1, tan 0 is 0. And we know natural log at 1 is 0. So we have only ln radical 2 plus 1 left. Correct? So we finish these sections. So thank you.